Hello to you. I'm Jessie Johnson. This is Mathematics, Principles of Exponents, First Order, Second Order, and Third Order Exponents. First Order Exponents are common exponents. Second Order Exponents are power to a power. Third Order Exponent is infinitum of infinitums. The first law of numbers is, what do the numbers chosen represent? The second law, every number chosen must have meaning as something real or actual. And to fulfill the first and second laws above of numbers, years, Y-E-A-R-S, 365 days, will be used for our purposes here. Now, the definition of an exponent. A number, the exponent, placed at the upper right position of another number, the base. To indicate how many times the base is to be repeatedly multiplied by the exponent quantity. This is called raising to a power. All exponents have two main units, the base, represented here by B, or bases, and the exponent, represented here by N, or exponents, plural. This N is raising B to a power, the power of N in this particular case. Now, how to do exponents. This is, as an example, 10 to the 6th power. This means to multiply 10, the base, 6 times over. 10 times 10, that's 2 of them, 1 and 2, equals 100, that's the result. Then you multiply it again by 10, that's the third 10, get the results, 1,000. The results multiplied by the fourth 10, that's 10,000, that's the result. Multiplied by the fifth 10, that's 100,000, get the result. That's the result. Multiplied by the sixth 10, that's 1 million, which is the result. 10 to the 6th power is equal to 1 million. That's how you do all exponents. Now, since we are going to use years, Y-E-A-R-S, we're going to go into energy. Number 1, a field. What is a field? A field is 2 or more location points, geometry. Number 2, energy is equal to E, equals the instantaneous field change, which is equal to E superscript I. Superscript I is the instantaneous time moment, which equals I. Subscript F, the subscript F is the field, which equals point locations, times C, which is the contoured or non-contoured field change. Now we'll go to 3. Energy is equal to 0, which equals subscript 0 times C. In this particular case, C means that energy is conserved in all open and closed, all open processes, which is equal to energy subscript 0 times infinity minus 1. We'll go to number 4. Energy subscript 0, which equals energy subscript C times infinity minus 1 times BIC, B-I-C, which means bounded, isolated, or closed volume system of processes. We'll go to 5, where E is subscripts or subbase 0 equals the quantity and the quality of energy is unchanged in all open and closed processes. This is E subbase 0 equals E subbase C. This is contoured or non-contoured field changes, which equals E. Equals C, in this particular case, conserved to infinity minus 1. We will go to combinations. A combination The formula for combinations is C, where x of x things taken x things taken n at a time, which equals x factorial divided by n. Permutations is P of x things taken n at a time equals x factorial. Now, for the definitions of a field: number 1, an open area of free expanse; number 2, an area of division of activity; 3, the sphere of practical operations outside of the main congested operations; number 4, an area of cleared enclosure; number 5, an area for exercise and maneuvers; number 6, an expanse constructed and equipped for specific activities; 7, a portion of an enclosed expanse conducted for events; 8, a space or surface of which something is drawn or projected; 9, the whole surface and or volume of elements; 10, a complex of forces or set of other elements that serve as causative agents; number 11, a set of elements that is a subject to and of operations upon; number 12, a region in which a given cause or effect exists; number 13, a particular set of elements of which the same types of elements are regularly recorded; number 14, a broad level expanse of fundamental essentials or irreducible constituents of a composite entity; 15, basic principles of a subject; number 16, a set of members of some configuration; number 17, an array of terms that creates determinants; number 18, a composition of forces, vectors, momentums, energies, basic to the nature of dimensions of creations and formations; 19, an elemental ground having specific dimensions, members, and activities; 20, a topic, subject, interest, specialization, profession, application, determinable values, actions, agents, etc. 21, a physical area or volume having specific constituents producing specific effects and causes, actions, reactions, and activities. Number 22, 2 or more location points, geometry. Now, first-order exponents. First-order exponents can be found in virtually every well-written mathematics books in existence. Second-order, and third-order exponents cannot be found in any mathematics books on Earth, but only on this particular video. Combinations and permutations. The number of combinations and permutations of every form, character, change of every and all energy, and energy changes that energy can go through in a second, minute, hour, day, week, month, or year, that composes the universe, cosmos, omnipan, or near infinity, also including how many times the utter 100% same identical thing in energy forms can happen, such as the Earth and the universe and every living thing reoccurring. Infinity minus 1 in exact 100% same identicality over and over again indefinitely, such as the combinations and permutations of energy, such as here, permutation P of, in parentheses, 10 to the 100, that's the base, 2, 10 to the 100th power, which is the exponent, these number of things, taken, this number of things, in parentheses, 10 to the 100th power, 2, that's the base, 2, 10 to the 100th power, which is the exponent, which is equal to n factorial, which equals x. Now, exponent operations, I will not state the formulas, but I will give the basis for those formulas. Number 1, multiplication, use this formula. 2, raising to a power, use that formula. Division, use that formula. 4, positive integral number 1 type, use this formula. 5, positive integral number 2, use this formula. Exponent root, use this formula or this formula, positive or negative form. Number 7, exponential fraction, use this formula along with this part where the arrow is pointing. Now 8, negative exponent, use where the arrow is pointing to this short formula here, use that formula. Addition, use this formula. Subtraction, 10, use that formula. You can stop the video at any point to read these formulas. Please do so. Stop the video at any point to read these formulas. Number 11, exponential series. Use this formula. Number 12, exponential function, gamma distribution. Use this formula. Number 13, exponential curve, power function. Use this formula. Number 14, exponential function. Use this formula. And 15, zero exponent. Use this formula. At any given time, stop the video so you may read all of these different formulas if you have need of them. Now, this is infinity, the symbol for infinity. This is the symbol for infinitesimal. Now, the largest number there is in existence when positive to infinitum, and the smallest number there is in existence when negative, infinitesimal. Hence, the largest number there is infinity minus 1 infinitesimal. Examples of first, second, and third order exponents. A, first order exponents forms A through D. B, second order exponents forms A through F. C, third order exponents forms A through F. We will start with first order exponents. First order exponents. Okay, let's begin. First order exponents forms A through D. This is common exponents. We are using years, Y-E-A-R-S, 365 days, of which X would equal. We'll start with A, 10 to the third power. 10 here is the base, 3 is the exponent. 10 to the third power equals X number of years. B, 10 to the third power is the base. 10 to the sixth power in parentheses, 10 to the third power in parentheses, 10 to the sixth power is the exponent, which equals X in number of years. Letter C. B is the base, which is 10 to the 500th power in parentheses, and the exponent to that is 100 to the 100th power equals X number of years, because energy is conserved in all open and closed processes. D, 10 is the base, and infinity minus 1, the largest number there is. 10 is the base, and infinity minus 1 is E, which equals X, number of years. Since energy is conserved, the universe never began, it shall never end, cannot be created nor destroyed. The universe is the totality of all outsides. Therefore, the universe itself has no outside, etc., etc. We'll go to B now. The second order exponents forms A through F. Second order exponents are power to a power. Once again, we are using years, Y-E-A-R-S, 365 days. We'll start with A, which is an external if you remember, a non-internal base. The non-internal base in this case is 100 to the 1,000th power, which is 10 to the third power here. 100 to the 1,000th power in parentheses. And in parentheses here is the exponent number 1. Exponent number 2 here. Now, exponent number 1 here is in parentheses, which is 1,010 to the third, which is raised to 1,000 to the 100th power. And since this is in parentheses, the second exponent is 10 to the 9,359th power, which equals x number of years. The form B is, when you see these straight lines, this straight line here, this straight line here, this is to give note that this is internal with the I in superscript, the I here in superscript to B, and number 1, number 2 base, and in parentheses 1,000 to the 1,000th power, which is 10 to the third power. In parentheses, once again in parentheses, 10 to the 12th power, which is 1 trillion, and it is raised, this is a base, it is raised to 1,000 to the 100th power. This is base, internal base, number 2, because of the straight lines here, and this is base, this is the totality, equals a single base, and it is taken up to 2 exponents. The first exponent is in parentheses is 10 to the 97th power, and the second exponent, exponent number 2, is 10 to the 6th power, which is raised to 10 to the 3,459,762 power, equals x number of years up here, equals x number of years down here. Now we will go to C of second order exponents. See, this is the base, internal base, there's a superscript I right here, and base number 1, and what happens here is that the base here is 10 to the third power, 1,000, and here's exponent 1 and 2. Internal exponents, internal exponents because of the 2 straight lines. That makes them internal, 10 to the third power, which is 1,000, taken to 10 to the 6th power, which is 1,000,000. And this base is taken to exponents 1, 2, and 3, 1, 2, and 3. In this case, 10 is taken to the 10 to the 339th power in parentheses. Also in parentheses is exponent number 2, which is taken to 10 to the third power. Is 10 to the third power, which is taken to 10 to the 4th power, which is taken to 10 to the third power. This is exponent number 2, is in parentheses, and exponent number 3 is take all of these up 10 to the 100th power, and so on. You see 3 dots right here. That means and so on. That means that 10 to the 39th power of exponents are written in this so on. 10 to the 39th power of exponents are written, that's more than one exponent written in this and so on of any sizes. And once this finishes, it comes here and so on, and within this so on is internal exponents here because of these 2 straight lines, internal exponent here, internal base here, internal exponent here. The internal base is 100 to the 100th power in parentheses. This is taken to the internal exponent of 10 to the 1,000th power. This is the base. And to that base is these 2 exponents, E1 and E2, which is 100 to the 659 power in parentheses, taken to 10 to the 7,913th power, exponent number 2, and so on. And within this and so on is 10 to the 10 millionth power of exponents is within this so on All of these are exponents, any sizes, and it is equal to x number of years. Now we'll go to D. We'll go to D. D form, that is, D form of second order exponents. This is B's, basis, in which you have a many internal exponents because of these two straight lines, and the number of bases inside of these two straight lines is 100 to the 100 power of bases, and this is taken to 10 to the exponent of 10 to the 6th power, or 1 million, which is the number of exponents of all sizes and all sizes, bases, and so on here. These 3 dots points down here. That means there are this number of exponents of all different sizes of, as a base, 1,726 as a base, taken to 10 to the 422nd power of different exponents of all different sizes until that's finished. Then you come here again, which has straight lines, which is a base. That means bases, so straight lines. And inside of these bases, internal bases and so on, you have 10 to the 12th power in parentheses taken up to 10 to the 1050th power, 50, which is an exponent, right? Which is an exponent, but creates this many bases. You have this many bases of every different size and every different kind in here, and this base is taken to this exponent here, and this here this is the number of exponents you have to this gigantic base, and that's in parentheses 10 to the 100th power. Then raise that to 10 to the 100th power of the number of different exponents inside of here, and all of those equals x number of years, because energy is conserved in all open and closed processes. Energy is open and closed to, cannot be created or destroyed. That will go all the way up to infinity minus 1. We'll go to E now of the form of E for second order exponents. For B number 1, here's 10 to the 6th power of bases, and the number of exponents here is 10 to the 13th power. Misread. 10 to the 6th power is the base, taken to 10 to the 13th power, which is the exponent. And you have 1, 2, 3 dots here, which points this arrow here, and right next to the arrow is a number 1. That means this whole thing right here is taken the first time. The first time it is taken until it is finished all the way at the end, until it comes all the way to the end for the first time, number 1. That means in parentheses is 10 to the 7th power taken to 10 to the 1000th power. And this is exponents of, in parentheses again, is 10 to the 6th power taken to 10 to the 1000th power. In parentheses again is 10 to the 1000th power taken to 10 to the 18th, which is in parentheses, which is taken to 10 to the 18th power, which itself is taken to 10 to the 105th power. And these are exponents of every and any sizes here. And once this one, number 1 right here, is finished, you go to right here. These are bases. See, base 1, internal, base 2, internal, base 3, internal. This equals a certain amount of bases all the way continuously. So you have in parentheses 10 to the 6th power taken to 100 to the 7th power, and this is the first internal base. And the second internal base is 10 to the 998th power, the second base, and the 10 to the 467th power is the third base, and so on. 1, 2, 3, so on. And this arrow is pointing down here for number 2. This was number 1. This is number 2. And the same thing is repeated as was repeated in number 1. You repeat the same thing here for the number of exponents that will be used inside of these 3 dots. Any sizes, and these are all exponents. And this equals x in the number of years, because energy is conserved in all open and closed processes. Because, why? Because if you can consider energy a closed, any point of space, a closed process wherein energy is happening, then you can create an infinity minus one of closed volumes where energy is, which would have energy be conserved. So energy is closed, energy is conserved in all open as well as closed processes, equaling infinity minus one. We'll go to form F of second order exponents, infinity minus one, and so on to this base, straight lines, to in parentheses 10 to the 100 power base 1, 2 taken to 10 to the third power, which is taken to 10 to the third power exponent. This is a base, and so on, wherein you have, where this arrow goes, 100 to the 78th power, number of different bases of every different sizes, of all different sizes, and when this is finished, it comes here to, in parentheses, 10 to the 100th power, taken to 1000 to the 10 to the 350th power of exponent number 1. And also number 2, 3, and 4 exponents, 10 to the exponent of 10 to the 106, taken to the 10 to the 809th power in parentheses, and then exponent 3 is 100 to the 100th power, exponent 3, and exponent 4 is 10 to the 6th power, which is taken to 10 to the 10,000th power, which is exponent number 4, and you have, and so on here, and inside of all of these exponents, all of these three and so on, is this, where the arrow is pointing, of 10 to the 1,016,799,537th power of exponents, small s right here, exponents. And once this is finished, once that's finished, it picks up at a base right here, 10 to the 10 taken to the 10th to the 9th power, which is also taken as an which is a base, taken to with an exponent 10 to the 500th power in parentheses. When both of them are put together, it equals the number of exponents right here. This number of exponents, the number of exponents is equal to a base of 10 to the 809th power, taken to 10 to the 905,286 power, which is an exponent. Here's a base, but this is the totality of exponents. And when that exponent ends, these three dots, 1, 2, 3, these three dots, 1, 2, 3, is equal to 296 taken to the 84th power of exponents, until you reach infinity minus 1 minus 10 to the 11th power, which equals x number of years. Now, to continue, C, third order exponent forms A through F. It should be F, but I forgot to put it. It says E right here, but it's supposed to be an F. But nonetheless, third order exponents is infinitum of infinitums in years. YEARS, 365 days. We'll start with A. Infinity minus 1, this is a base. In parentheses, infinity minus 1, first exponent, to the infinity minus 1, second exponent, equal x, number of years. B form is where you have these two straight lines, where the internal base is infinity minus 1, to the infinity minus 1, exponent 1. This is a total base, because these two lines make it a total single base, and this is taken to infinity minus 1, the first exponent with the 1 here, which equals x, number of years. Now, C form. This here is, as you can see, includes B internal base, 1 and 2, which is infinity minus 1 taken to the infinity minus 1 power. The first base 1. Base 2 is infinity minus 1 taken to the infinity minus 1 taken to, in parentheses, infinity minus 1 power, which equal the totality of all these bases. And this base, this totality of all bases, is the number of bases in this is taken in parentheses infinity minus 1 to the infinity minus 1 of exponents. This is the first exponent. And infinity minus 1, this is the second exponent, which equals x amount of years. We'll go to D. Once again, you have straight lines, so you have internal bases also, which is infinity minus 1 and so on, which is equal to infinity minus 1 number of bases, all the way to infinity minus 1. In these two vertical straight lines to the exponents of infinity minus 1, 2, and so on, to infinity minus 1 of exponents, which when that ends, this, it picks up here at infinity minus 1 minus 10 taken to the 10 to the 167th power, which equals x amount of years. We'll go to form E. Right here, once again, this is a base, a total base, but that base is made of internal bases and internal exponents. And in this case is infinity minus 1 taken to the infinity minus 1 exponent power, which equals a single base, which is taken to the exponents of exponents 1, 2, 3, and 4. These are exponents. So the infinity minus 1 taken to the infinity minus 1 taken to the infinity minus 1 taken to the infinity minus 1 of 4 different exponents equal to those exponents taken to more. The exponent, forgot to put the t's here, but exponents, t's here, infinity minus 1 to the infinity minus 1 in parentheses, and this is taken to infinity minus 1, which equals x a number of years. Now, taken for the F form, infinity itself minus, in parentheses, infinity minus 1 minus, in parentheses itself, 10 to the 6th power, taken to 10 to the 691st power equals x number of years. This one here is not G. This is simply a symbol to show you something, and of which infinity minus infinity equals infinity. Now, I want to thank everyone for listening and watching, every single one of you. And I want you to please share this video and subscribe, and have a very good day. You will find this video in science, listed under science. And once again, have a fine day.